This video is about molecular geometry, and it's going to explain how to make the basic structure and then determine with an AXE chart what shape that molecule is going to be. So let's take an example off of the worksheet, SiCl4. And there are a set of rules, and the first rule is that the loner, which in this case is your Si, he's all by himself, that's why I'm calling him the loner. See, there's 4 Cls. The loner goes in the center. So who's ever alone is in the center. And then I connect however many elements I have off of that central atom. So I have 4 of those. That's why I'm making 4 Cls. Now I've got to count up my valence electrons. So I'm going to need to look at a periodic table to do that. So in this periodic table, I'm going to look for Si. Here's Si. How many valence electrons is located right up here? That right there is the number 4. And while we're looking at this chart, the other thing was Cl. And if you look up here, this lets you know that there are 7 valence electrons. And that goes for everybody in that family, not just chlorine, not just silicon, but anybody that's in that same family up and down is going to have that many valence electrons. So back to our practice problem, I've got 4 valence electrons for an Si, and I have 7 for each chlorine, and I have 4 of them. So that's why I'm saying times 4, because there are 4 of them. So that's 28, and 28 plus 4 is why I have 32 valence electrons. Now, when I'm going to distribute my electrons, the rule is that each one of these sticks is worth 2 electrons. So the stick you used to connect was worth 2. So far I've used up 1, 2, 3, 4, 5, 6, 7, 8. So 8 valence electrons were already used with each of the lines being a valence electron. So then I'm going to distribute the remainder of these electrons. That's why I'm starting out saying 8. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So as you can see, I have distributed 32 electrons, which is the number of electrons that I needed to distribute. The next thing, I go around and check if I have all 8 to make everybody meet the octet rule. It's called the octet rule. And that means that everybody has 8 electrons. So does this chlorine have 8? Yes. 1, 2, 3, 4, 5, 6. And remember, this was worth 2. 7, 8. This guy, 1, 2, 3, 4, 5, 6, 7, 8. Happy. This guy, 1, 2, 3, 4, 5, 6, 7, 8. Happy. This guy, 1, 2, 3, 4, 5, 6, 7, 8, happy. And how about silicon in the center? 1, 2, 3, 4, 5, 6, 7, 8. So everybody here has met the octet rule, and they're all happy with 8. So let's figure out the shape. The A stands for the central atom, and the answer will always be, how many central atoms do you have? Well, only one thing can be in the center. So how many central atoms do you have? The answer is always going to be 1. The next thing is the X. The X stands for how many things did you connect to the central atom? And for this one, it's 4. So that's elements connected. So I'm going to say connected to central atom. Okay, and the E is extra electrons. Now, I finished my 32 count, and I didn't have any extra electrons, so that would be 0. And the E is standing for extra electrons that are pairs, extra electron pairs. And I don't have any. I'll, of course, do one that has it, but that is extra electron pairs, and that pairs word is important. So I'm going to go look at an AXE chart. So I did it on this actual document, so scroll down here. I'm looking for a 4, 0. So if I look on the AXE for the 4, 0, it makes this shape of this molecule tetrahedral. So for the shape up here, it would be and this is where I got that from. An X of 4 and an E of 0, that made me tetrahedral. So that is example number 1 on molecular geometry.